Today we're going to look at writing algebraic expressions. So what is an algebraic expression? It is a number sense without an equal sign, because if it had an equal sign, it would be an equation, and it contains at least one variable and one operation. So here we see our variable x, operation subtraction. Variables x and y, operation addition. Variable a, we don't see the actual operation here, but when you have a number next to a variable, that means multiplication. So therefore, we do have our operation. When we are going to be writing expressions, we need to pull out key words that tell us different operations. Up here are some examples. It's not all of the examples. For multiplication, some words that sometimes people miss when we see of, as in like fractions of, that means multiplication. Per, for every, each, one, those are ones that are commonly used, okay? So let's look at number one. The quotient of a number and 7. So I'm circling some numbers in there. I'm gonna underline our unknown. We don't know what the number is. So I am just going to use n equals a number. You can use different variables. You try to make it make sense for the problem, or just use our default variable of x. Then our keyword that tells us the operation, quotient, tells us division. When we have division, we kind of want to get away from using the division sign, just like we are getting away from using x for multiplication, because that looks like a variable. So how I'm going to represent this is using a fraction. And when it's quotient, we just go in the order of the unknown number and 7. Number 2, 5 times the sum of a number and 7. So defining our variable, again, we have a number which is unknown. Maybe this time I'm going to use x equals a number, since x is our most commonly used variable. Since I have two numbers, it's likely that I have two operations in this one. So when I look at this, I see times that tells me multiplication, and I see sum that tells me addition. What is important here is that we are multiplying 5 times this entire sum of a number and 7. So I'm going to represent that in parentheses. So we're going to do 5 times our sum of our unknown number and 7. So we're multiplying 5 by this entire sum. Number 3, John is 3 years younger than twice Sarah's age. I'm going to circle those numbers in there. In this case, we don't know John and we don't know Sarah. But since we are relating John to Sarah, Sarah is going to be my unknown. Because once I know Sarah, I can know John. A lot of times with word problems like this, we use letters that represent the things that are unknown. I don't really want to use S for Sarah, though, because it can look like a 5. So maybe I'm going to say A equals Sarah's age. Or maybe you just defaulted to X. There's two numbers, so there are going to be two operations. I see younger than, which tells me subtraction. And twice is not only a number, but it is the operation of multiplication. Whenever we see younger than, yet less than, more than, older than, it has to go after. So 3 years younger than means I'm subtracting 3 from something. What am I subtracting it from? Twice Sarah's age. So we are subtracting it from 2a. Number 4, 2 less than 8 times the length. So I'm circling my numbers. And our unknown here, we don't know the length. I'm going to use a cursive L to represent length, because if I use just a straight L, lowercase, it kind of looks like a 1. Maybe in this instance, you can actually use an uppercase letter. 2 less than, so less than is telling me the operation of subtraction. 8 times the length times is telling me multiplication. Whenever we see less than, younger than, older than, more than, it goes after. So 2 less than means we're subtracting 2 from something. What are we subtracting it from? 8 multiplied by the length. So 8L. It's 2 less than 8 times the length. Seven times the sum of a number and 9. So I see my numbers in there. Our unknown, we're back to an unknown number. So I'm going to say n equals a number. And I have those 2 numbers, so I should likely have 2 operations. I see times tells me multiplication. I see sum tells me addition. So it's 7 times the entire sum. So I'm going to use parentheses. 7 times our entire sum of that unknown number and 9. Number 6, you bought a magazine for $5 and 4 erasers. So in this case, there's not necessarily 2 descriptive words that tell us the operation. The word and does tell us that we're adding them together, so I do know that, okay? And the magazine, we know that we just bought the one magazine, a singular magazine for $5. What we don't know is how much the erasers are. So that's going to be our unknown. So E equals eraser cost. So for my expression, I'm going to take my magazine of 5, plus I'm going to add in, we have 4 erasers. Or you could do the reverse. 4 erasers plus 5 would mean the same thing. All right, so now let's look at some where we're then going to give you some values to go back and plug in and evaluate. So number 7, Terry bought a magazine for $5 and 2 bottles of nail polish. So similar to the one that we just did. We have that singular magazine for $5 and then 2 bottles of nail polish. In this case, we don't know how much those nail polish bottles cost. So I'm going to have that be my variable. N equals nail polish cost. For our expression, we bought that $5 magazine plus 2 whatever the nail polishes cost. Now it wants us to go back in and plug in and say, okay, well, what if each bottle of nail polish costs $3? So I want you to show me, even though I know you can do this in your head, I want you to show me plugging it in. We're plugging in $3 where N is. So you're doing 2 times 3, which is 6, or 5 plus 6, which is a total cost of $11. Okay, number 8, Sam bought a box of popcorn for $3.50 and 3 medium drinks. Write an expression to represent the total amount she spent. So we know it was a singular box of popcorn. We don't know what the medium drinks cost. So I'm going to say D equals drink cost. So for our expression, it's $3.50 for the popcorn plus 3 times whatever a drink costs, because we have 3 of them. Now we're going to evaluate given the information, find the total amount if 1 drink costs $1.50. Again, even if you can do this in your head, I want you to write it out. $3.50 plus 3 times that singular drink, that's $1.50. So I'm going to multiply 3 times $1.50 to get $4.50. And we're going to add that $3.50 to that to get a total of $8. All right, last one. Erica owns and operates her own food truck. She sells burgers, B, for $3.25 each, and hot dogs H for $2 each. So in this case, we actually have two variables. So B is representing our burgers, and specifically the burgers sold. And then H is representing the hot dogs, and specifically the hot dogs sold. So for our expression, she sells burgers B for $3.25, so it's $3.25 times however many burgers, plus hot dogs H for $2, so 2 times however many hot dogs. Now when we're gonna go in and calculate 4 burgers, 6 hot dogs. So we're doing $3.25 times 4 burgers, plus we are doing 2 times 6 hot dogs. So $3.25 times 4 is 13, plus 2 times 6 is 12. When we add 13 plus 12, we get $25.